Okay, friends, today we are going to speak about compound microscope. And in compound microscope, we will have to initially draw a lens. It's a convex lens, and this is our objective lens. Then we will have to draw our principal axis. This is our principal axis. Then in front of the objective lens we have to place our object, and this object is placed just beyond of, let's call this object as AB. It is placed just beyond of. Then we initially start with a ray which is starting from the head of object and it is passing through the optic center. A light ray which is passing through the optic center will pass without any deviation. Therefore, we have completed a light ray like this. Then next we are taking a light ray like this. This is a light ray which is passing parallel to the principal axis, and it is passing parallel to the principal axis. It should pass through the focus and it should pass like this. And these are the two light rays, and at the intersecting point of these two light rays we will have an intermediate image, and we'll calling it as A dash B dash. The nature of intermediate image is real and inverted. Then we will draw another lens which is having these two light rays inside it. That lens is also a convex lens, and this is our eyepiece. This is our eyepiece, and I'll extend these two light rays like this. Then what's happening is these two light rays will pass through the lens and it should pass like this. Then we will get an image over here. In order to simplify the situation, let me draw a line which is starting from the optic center of eyepiece and it should pass through this intermediate image. Let me draw a dotted line like this. This is how we are drawing systematically the ray diagram of compound microscope. That is, we have to draw this line, and on this line I am drawing an image over here. Why I am drawing a dotted image over here is it's because it is virtual, and let me call it as A double dash B double dash. But you might wonder why or how I am drawing it over here. Let me complete it. I am drawing an image over here. Then assume that a light ray, or if I am drawing a dotted line from this point to this point, I could draw a dotted line like this. Can I? Then I am extending this as a bold line. Then from here to here also I am drawing a dotted line. Then I am extending it to a bold line like this, and you just focus your attention. Assume that one light ray is traveling like this and it is passing through the first lens. It is moving like this and finally it is reaching over here and it will travel like this. Then the another light ray, it will pass like this and it will reach the eyepiece like this and it will emerge out like this. And the person who's viewing from here, let this be our eye, the person will have a sensation of these two light rays coming to his eye like this, and it might be coming from here. Instead of seeing this object, he'll see an inverted, magnified and virtual image. Then let's mark these distance. This is our objective lens and this is our eyepiece. This distance, it's marked as UO because it's the object distance of this objective, and this distance, it is marked as VO, image distance of objective. This distance, it's marked as UE. It's because this is an object for our eyepiece. For eyepiece, the object is this and image is this. Therefore, this distance is called as VE, image distance of eyepiece, and VE will be formed at least distance of distinction. It will be formed at least distance of distinction. This is the ray diagram for a compound microscope. Then now we have completed the ray diagram of compound microscope. Then let's go for the magnifying power of compound microscope. Magnifying power of compound microscope. We know magnifying power is HI by HO, height of image divided by height of object, and this complete system is the compound microscope. Which is the object of this compound microscope? The object of this compound microscope is AB. Which is the image of this compound microscope? The final product or the final image of this compound microscope is A double dash B double dash. Therefore, I could write M is equal to HI. HI is image, that is A double dash B double dash divided by object, height of object, that is AB. After writing this, I am just multiplying this A double dash B double dash divided by AB with an A dash B dash divided by AB. If I am A dash B dash divided by A dash B dash. If I am multiplying and dividing with the same thing, the equation is not changing. Then let's interchange the position, that is A double dash B double dash divided by A dash B dash into A dash B dash divided by AB. There won't be any change in the equation since we have just interchanged these two terms. Then focus your attention on this. Who's this? A dash B dash divided by AB. A dash B dash is the image of objective. Image of objective. And AB is the object of objective. Therefore, A dash B dash divided by AB is the HI by HO of this objective. Therefore, I could write it is the magnifying power of objective. Magnifying power of objective. Likewise, next, the A double dash B double dash divided by A dash B dash. The purpose of this eyepiece is creating a magnified image of this image. Therefore, A dash B dash image is formed at A double dash B double dash. Therefore, the function of eyepiece is it is forming the magnified image of A dash B dash. Therefore, for eyepiece, A dash B dash is the object and image is A double dash B double dash. Therefore, we could say magnifying power of eyepiece will be HI by HO, that is A double dash B double dash divided by A dash B dash. That means I could write this as ME and this as MO. Therefore, we could write the magnification equation like this, that is M is equal to ME into MO. This is one equation that we have to remember. Total magnifying power of the compound microscope is magnifying power of eyepiece into magnifying power of objective. ME is magnifying power of eyepiece, MO is magnifying power of objective. Then, if we are simplifying it further, we could write magnifying power of objective is objective lens is behaving like a simple lens, and we know the magnifying power of a lens as M is equal to V by U. Therefore, by using that concept, MO can be written as VO by UO, since it is magnifying power of objective, VO by UO. And looking at this eyepiece image formation, the eyepiece is actually behaving like a simple microscope. Eyepiece is behaving like a simple microscope. Therefore, the magnifying power of eyepiece, we know the magnifying power of a simple microscope at D distance, it is 1 plus D by F. We have studied it in the derivation of simple microscope. Therefore, magnifying power is 1 plus D by F. Therefore, ME will be 1 plus D by FE. This is the magnifying power of eyepiece. Therefore, we could write this effective magnifying power as m is equal to VO by UO into 1 plus D by FE. This is the magnifying power of a compound microscope, and this is magnifying power if the image is formed at d distance. If the image is formed at d distance, we have to remember another magnifying power if the image is formed at infinity. If the image is at infinity, then magnifying power of eyepiece, instead of 1 plus d by f, it will be d by f. Therefore, effective magnifying power of the compound microscope will be MO is VO by UO into ME is D by FE. This is the magnifying power at image at least distance of distinction. This is the magnifying power image at least distinction. That is least distance of distinction. Then we will have to learn an approximate formula that we could use in calculation purpose and all. What did I say about this object? Did I say the position of object? Yes. If you're recalling that, I was saying the object is placed just beyond f. And since the object is placed just beyond f, instead of this UO, we could approximate it to FO. Why? It's placed just beyond f. And the distance between the two lens, it is called as length of microscope tube. What is L? L is the distance between the two lens. It is called as length of microscope tube. And actually L is VO plus UE. But VO is much greater than UE, and if VO is much greater than UE, we could write L is approximately equal to VO. Then we could write this equation as M is equal to, instead of this VO by UO, we'll write FO by L. I'm sorry, it is, let me write it over here, M is equal to VO is L, UO is FO, L by FO into 1 plus D by FE. This is the formula that we could use for calculation purpose, and in this case also the approximate formulas M is equal to L by FO into D by FE. This is the formula we could use image at infinity. This is the formula that we have to use for image at least distance of distinction. Hope you are clear.